Hello everyone. I hope I am visible and audible to all of you. So today we will be talking about another problems on list and forward list. Yesterday we have seen list and forward list. So today we will be solving some question on this. Okay. So basically yesterday we have seen forward list and today we will be discussing about list. Okay. So we have already seen. Let us revise what we have uh, learned yesterday. So basically we talked about forward list and we know that forward list is nothing but a single linked list, and in order to use hashtag basically in order to use single linked list we use forward list and we include a forward list from here. And then we have seen what are the ways for declaring and initializing the forward list. So here we have seen forward list int L, and we are declaring some values like 1 2 3, and then we are pushing the values front 100, and then we are pushing another values 200, and then in order to remove the first element we use pop front, and we also seen complexities for all of them. Okay, so complexity here is order of 1, and you can see we use assign in order to assign some values to the linked list, and here you see we are declaring some values like 11 12 13. In order to remove we use l.remove. Basically it removes all the instances of 3 in the linked list basically. Okay, and in order to assign some values to another linked list we use l2.assign. Okay, where l2 is nothing but the single linked list. Okay, and from begin to end we have seen how we assign some values to that. Okay, and one more we have seen, if we try to use the pushback function for the single English, it shows some error, but it will work fine for the list, which will be seeing in the few minutes. Okay, so that is what we have done, what we have learned, and we have already seen l1.assign. So if you want to give some number of values, for example 5, and basically that is the number of values, number of times the value we want to insert on the linked list. Okay, so the value inserted here is 10. Okay, and it is inserted 5 times, so 1 2 3 4 5. Okay, so 5 times the list is the value is inserted here. Okay, and then we have also seen some values. For example, here we have seen insert after function. Okay, insert after and emplace after. We have talked about insert and what is the difference between insert after and emplace after, and then we have seen erase after. Okay, so what this function does and how the iteration is moved to the next values, and then we have seen normal way of printing the values in the linked list. So we have used this for each loop, and we have also seen how we can basically print the values using normal iterator based solution, iterator based loop basically. Okay, and we also seen some functions like clear functions, empty, reverse function, merge functions, how they are basically when you have two linked list and when they are sorted, and we use this merge function so that we can move elements from one linked list to the another, and the second linked list will become empty after merging. Okay, so L1 will contain all the values. Okay, and we have seen sort function. Okay, so we have already seen this, the complexity is n log n. Okay, for this sort function. And so today we are going to talk about the list, and we'll also be seeing one question which will be based on the list. Okay, so that is basically Joseph's problem we'll be seeing at the end of this explanation. Okay, so let us start. So in order to declare a list, so first, what is this? List is nothing but a doubly linked list. Okay, so it is nothing but doubly linked list, and you can declare using like this. Okay, so list int of L, and you can see we use pushback function also, push front also. Okay, and then we use iterators for printing the values. Okay, and when you can use pop front and basically push front and pop front. Okay, so basically there are two values. This should be back actually, pop back you can see. Okay, so let us try to implement that in code editor. So let me erase this one. So let us comment this so that we can use this code in the further part. And then here we can write all of the code. So let me quickly write all the bits /stdc++. So we will not in this, if you are including like this, then you need not to include every container by writing them. For example, if you want to use vector, you need to use #include vector. But if you are using bit /stdc++.h, then you need not to use that. Okay, so we can just use this namespace, and then we can just simply write our main function and then return 0. Okay, so first let us declare a list, and that we are taking int type, and we can call that list as L, and let us give some values. So values can be 1, 2, 3, and when you try to print, so I'm just using this for each loop for printing, just so that we can just visualize what we are writing. And let us print some spaces here, and at the end we just simply print and L here. Okay, so let us try to run now. So the values you are getting, so basically it should be here, my fault. So the values you are getting is 1, 2, 3. Okay, so basically this value are set in this list. Now let us try to write some function like pushback, and what basically pushback will do, it will append values to the end of the linked list. Okay, now let us do push front and then see what will be the output. So let us push front 0, and now let us try to run the code. So you can see the values which we are getting is 0, 1, 2, 3 and 4. Okay, so basically initially the values were 1, 2, 3, but when you used pushback function, then the value 4 is inserted at the end of the list, and push front will be just insert the value 0 at the beginning of the linked list. Okay, and when you try to pop front, so if you try to do something like l.pop front, so it basically removes the value 0, and the values which will be getting is 1, 2, 3 and 4. Okay, now one more thing is, if you directly want to get the value, so let us try to print the front. So if you do like this, l.front, and then we just print backslash in here, and when you try to run the code, so you can see the values for the front we are getting is 1. Okay, similarly for if you try to write back here, so you will be getting the back value here. Okay, so at the end the value is 4 now at this moment. So that is how we have talked about these functions. Let us move ahead in the explanation. So this is basically using for each loop. If you want to use iterator, so the iterator can be simply iterated using, so suppose you want to make the iterator for this list. Okay, so you simply need to write like this, iterator, and we can call that as it. And what we can do, we can simply use it equal to we are calling that list as L, and it will be basically pointing to the L.begin. Then we can run till L.end, it not equal to L.end, and then it plus plus, and simply print the values by dereferencing the iterator and some spaces after that. When you try to run the code, you will be getting the values as 1, 2, 3 and 4. Okay, so if you want to avoid this writing this lengthy statement, you can simply use auto there. Okay, so let me comment that, and if you try to run something like auto it, so it is basically you need not to write this whole statement. You simply it will automatically detect the type of iterator it has to be. So basically this iterator is pointing to L.begin, and L is nothing but list, so this it will become the iterator for the list. Okay, So when you try to run the code, you will be getting the same result, which is nothing but 1, 2, 3 and 4. Okay, so let us move ahead. So now we are talking about the insert function. So basically, suppose the values are something like, let me write this and show you. Okay, so let me get rid of this and we can use this. Okay, iterator. Now when you try to do something it equal to L dot insert, and you can pass it here, and then the value you want to print is 15. Okay, so basically you want to insert that, and at what position you want to insert. So suppose it is pointing to L dot begin. Okay, so begin is nothing but the value in English which is pointing, basically it is the first value. Okay, so basically the 15 will be inserted before 1, and when you try to print, okay, when you try to run the code, so you can say, we need to remove that, my bad. So when you try to run the code, so you will be getting the value 15 here. Let me check what is the error here. So basically we are not printing, so let us try to print. So use this for loop here, and when you try to run the code now, so you can see the value 15 is inserted before, or basically it is inserted at the position which we are passing. For example, we are passing the iterator which is pointing to L dot begin. So begin will be pushed again, begin will be inserted at the that position. Now if you try to run this code, basically copy this code, okay, and again you can see when you try to do something like 16, so can you guess what will be the output now? So basically 16 will be printed, it is printed before. So basically iterator was after insertion also, it is pointing to the begin only. So begin position will be updated again and again when you run the code here. Okay, now when you do something like L dot end -1, okay, so can you guess what will be the output? So it will not run because it is not pointing to the end. Okay, so when you try to run this code, so you can see the 16 is printed at the end -1. Okay, so basically 4 till 4 we were having the elements, because we have pushed the elements here, and then we have let me get rid of this so that we can get, and let me get rid of all this as well. And you can see we are inserting the iterator at the end. So we are getting, first we are getting the 15th value 15, and then we are getting the value 16 here. Okay, so that is how you insert at the end. And if you want to get some values, for example, let me show what will happen if you do like this. So let us try to run this code. So you can see we are getting the value 15 is inserted 2 times at the given position. So iterator was basically pointing to the end. Now when you try to run, when you give the third parameter 2, so it will insert that value that many times. So at this time we are inserting 2, so at this time 2 will be, basically the 15 value is inserted 2 times here, and 16 will be inserted after that position. Okay, now we have already seen this one, let me show you again. So when you want to print the size, okay, so we can directly use L dot size, and when you print, you will be getting the size of the linked list. So in this case the linked list is 7, and the values are nothing but 1, 2, 3, 4, 16, 15, 15. Okay, so that many values are there in this linked list. I'm now talking about the complexities. Before complexity, we have also seen this one. So basically, if you want to remove all the occurrences of certain elements, for example, you can see we have 15 here 2 times, and if you want to remove, then you can simply use L dot remove, so it will just remove all the occurrences here. Okay, so let us try. So if you do something L dot remove and you give some values like 15, and again when you try to run the code, you can see the 15 value will be now removed. Okay, so the 15 values are now removed, basically they are deleted from that. And now merge function we have already seen in the linked list. Linked list behaves similar to that here as well. So it is basically merge sort which we have seen. It basically takes two linked list and then merge according to the sorting order. Okay, so basically the L1 and L2 are both sorted linked list, and then it will take the value which is lesser, and then it will take the value from the other linked list which is just greater than the element. Okay, so that is all. And if you want to use erase function also, so basically this iterator, the value you want to erase, you need to pass into the iterator. For example, if iterator is nothing but suppose L dot begin, so begin iterator, it will be pointing to the beginning. Okay, here it will be pointing, and then if you want to erase, so you simply use L dot erase function here and it will point here. Okay, so after erasing that values, it will just point to the next element. So here it will be pointing after the erasing. Okay, now let us talk about the complexities of the functions which we have discussed. So for the front, in order to find the front, back, size, if you want to know the size of the linked list, then begin, then end, erase, push front, pop front, and push back, and push front. This all the time complexity is order of 1, and this values which is nothing but L dot reverse. So basically it helps to reverse the linked list, and L dot unique and remove remove. Okay, which we have seen L dot remove is order of n complexity, and sorting is, we all know, it is n log n. Okay, now this is all about list. Now let us see the linked list and one problem based on the linked list and this forward list and linked list basically. So the problem name is Josephus problem. It is very famous problem. So what is the problem statement says? So suppose you are given n people and they are 0 indexed. So it will start from 0 and it will go to 6. So there are basically 7 person starting from 0 up to 6, and every third person has to be, you can say, killed or something like that. So every third person has to be removed from this circle. So it will start from 0. Okay, it will start from 0 and every third person, so it will go on a clockwise direction. So basically it will start from here, first, second and third. So this 2 will be removed, then first, second, third, this 5 will be removed, first, second, third, this 1 will be removed, first, second and third, this will be removed, then first, second, third, this 4 will be removed, first, second, third, this 0 will be removed. So the value which remains now is 3. So how we can do that? Basically this is what the problem statement says, and we want to do this using linked list. So how can you do that? So you can try along with me. So basically the approach is very simple. So basically there is nothing like circular linked list in this C++. So basically we'll be using the normal list, and we'll be using some modification so that it behaves like linked list. So the improvement which we can do is the adjustment which we can do is, if the pointer is pointing to the last, so we can just point that iterator to the beginning of the list. Okay, so suppose this is the linked list. Okay, and when the iterator reaches here, so we can simply point this iterator to the beginning so that it behaves like a circular linked list. Okay, so this is circular linked list. Okay, and it will start from here, and every third person has to be deleted. So when it reaches to the kth person, so we are calling that is k here. So if it reaches kth, so we will delete that. We will just erase that. Okay, so we know the erase function which we have already seen. So we will be erasing that, and once we are erasing, we will start our counter again, and we will go up to the k. Okay, and then we will again erase that, and then we will go to the k, again erase that. Okay, so when we are reaching to this position, we will directly point to the beginning, and we'll again start with the k. So all this element in this way will be going an iteration, will be going on doing the iteration. And when we are having the size equal to 1, at that time whatever the value is there remaining, we'll be just printing the value. So one thing you can note that this is not the efficient solution. We are just learning this so that we can understand the usage of the list container which we have studied so far. Okay, so the the complexity of this solution is nothing but n into m, n into k basically for k such operations, and there is order of n solution as well. Okay, that will be covering in the latter part when we discuss something about of degree and all. So at that time we'll be having look at this solution. So basically today we are going to see only this solution. Okay, so let us try to solve this question, how we can solve this. So let us jump into the code editor, and let me get rid of this code which we wrote, and let me uncomment all this value. Okay, so what we are doing here, so basically first whatever the values are there, so I am just assuming the values as default. Okay, and I am just pushing all the values 0 to 6 manually in the list. Okay, so the now list contains from values from 0 to 6. So that is the first step. And now we are declaring the value k as 2 or k is 3 basically. And initially the iterator is pointing to the beginning of the list. Okay, now the condition which will basically guide this while loop is nothing but L dot size greater than 1. Okay, because if it is 2, then we need to, because only the condition here is the person cannot kill himself. So the person which will be remaining at the end will not kill himself. Okay, so other person will be killed. If there are 2 persons, then obviously one person of those 2 will be killed. Okay, and when there are 3, then 2 will be killed, then 4, then 3 will be killed, 1 will be remaining. So the condition here we are given is L dot size should be greater than 1. Okay, if it is greater than 1, this while loop will run, and in this while loop, let us see what we are doing. So we are just running this for loop k times, basically k minus 1 times, and when we are when the position is up to the k, which will be directly pointing to the kth term within the third term. So our counting will start from 1, it will go to the k minus 1 value 2 times, then it will be then the iterator move will 2 times, but at the end of this for loop the iterator will be pointing to the third element. Okay, but in this also we are checking one condition. For example, if there are only 2 values, so suppose by iteration only we are reaching to the end, so in that case what we are going to do, we are just going to point our iterator to the beginning. Okay, so basically it will point again to the value basically to the value 0, the person 0. Okay, so this is the condition check we are doing here, and when we are getting out of this loop, we'll be pointing to the person which we want to delete or remove from the circular linked list or something you can take. Okay, so at that what we are doing, we are just erasing that element, and after erase, once we erase that element, the iterator will be pointing to the next person or the iterator plus plus. So in that case also we want to check, suppose the element we are want to insert is the last person, and once we are deleting, then it will be pointing to the end. Okay, so in that case what we want to do, if that person is pointing to the end, so in that case also we are pointing that person again to the beginning of the linked list. Okay, so this is how it going to happen. And once we are doing these operations, and at the end what we are going to do, we are going to simply print the value which is basically at the beginning. Now L will be the begin will be pointing to the only one value. Okay, and now when you try to print, suppose we are printing the size, whose size, basically the linked list size, and when you try to print, okay, so basically we want to remove the comment here. Okay, so when you try to run this code, you can see the value is 1 only, and if you want to print that value, So you can use simply L dot begin, and we want to dereference, so we are using the pointer here. And when you try to run this code, you can see the value which we are getting is 3, which we have already seen. Okay, suppose there are two elements, only 0 and 1. Okay, now the k is 3, so let us try to run. What will be the solution? You can see the value will be 1, because from 0, when we start a counter, so 0 is 0, or 0 is first, 1 is second, then third is 0 again. So this person will be killed and 1 will be remaining, the output is 1 here. Okay, so the complexity for this solution is nothing but order of nk, and we'll also be seeing how can we optimize this using the recursion, and then ending up with a DP solution. Okay, so that is, I guess that's it for this stream. So today and yesterday's stream we have covered our forward list and list, and we have also seen some questions basically based on this. And now in the next part, hopefully we'll be starting with the deck and then move to the queues and stacks. Okay, so that's it for this stream. I hope you liked the video or stream basically, and if you are watching this for first time, so just go and subscribe to the YouTube channel, so that you can come to know about the latest stream which we do. Okay, so basically in this channel we do the daily live stream, which will be basically helping the person or people who are preparing for the placement. So we'll be covering their basics, and that's it for this stream. Okay guys, thank you for watching. We'll meet in the next stream with another such interesting live streams. Okay.